This is a recap of the ideal gas law. It's the equation that shows the mathematical relationship that describes the behavior of a gas. The relationship exists between the gas's pressure, volume, number of moles, and temperature. The equation PV equals nRT includes R, the ideal gas constant. Each component of the formula has an associated unit that goes with it. It's important to note that the unit for the ideal gas constant, R, depends on the unit of pressure that's being used. The ideal gas constant is derived from all of the STP values. As you can see from the formula below, that when pressure is in atmosphere, the value for R is 0.0821 liter atmosphere per mole Kelvin. When 760 millimeters of mercury are used as the pressure value at STP, the answer is 62.4 millimeters of mercury liter per mole Kelvin. This table demonstrates all of the possible values for R. The ones circled are the ones most commonly used in our class. Pause here to study this example of solving a problem of an ideal gas. The property of density of a gas can also be explored. Density is a ratio of a gas's mass to its volume. With some rearranging of the ideal gas law formula, we come up with the formula that molar mass M is equal to dRT over P, the density times the ideal gas constant times temperature divided by pressure. Again, ideal gas constant depends on which unit of pressure is used. It's important to note the units. Density has a unit of grams per liter, molar mass has a unit of grams per mole, and temperature always has to be converted to Kelvin. Finally, in this unit, we discussed Graham's law of diffusion, which discusses the rates at which gases will move through a space. There's a difference between the definition of effusion and diffusion. Effusion is when a gas escapes. Diffusion is when a gas disperses through a space. Pause here to study the formula in the example problem for finding the rate of effusion of a gas. We are discussing this in terms of a ratio between gas A and B. The answer is the inverse square of the molar masses of the gases, where the larger gas is divided by the smaller gas and then the square root. In this particular example, the final answer of 3.98 means that hydrogen, the smaller gas, the lighter gas, the faster gas, will effuse 3.98 times faster than oxygen. Look over the three equations one more time that deal with ideal gases. First, the ideal gas law, PV equals nRT. Second, the density of gas is found by MP equals dRT, mop the dirt, where big M is molar mass, and D is density, which can be substituted with mass over volume. And finally, Graham's law of diffusion, where the ratio between the two gases is defined as the square root of the inverse of the molar masses of the two gases.